Back in the last session, we started solving problem number 2 from student workbook, and we were in between, and I explained the CMOS inverter fundamental operation, not completely, and we have dealt with what minimum input voltage and maximum input voltage, that is nothing but logic 0 and logic 1, that is what we had seen. Okay, now let me explain. Therefore, if you continue, I am just repeating the problem. When input is equal to 0, under steady state we got output 5 volt. When input is equal to 5 volt, under steady state we got output is equal to 0. That is nothing but your inversion. 1, 0, 0, 1. Simple. Okay. But I want to explain, when input is 0, yes, output is 5 volt. When input is 0, output is 5 volt. Right. But when input is changing like 0, 1, 2, 3, 4, 5, then your output will be 5, 4, 3, 2, 1, 0. Definitely, right? That is what. Why? If you observe clearly, input is 0, output is 1. Input is 1, output is 0. Inversion. That is nothing but your inverter, but defined with the logics. Logic 1, logic 0. What it may be, right? Now what I want to explain is, when input is increasing, your output will decrease. Inversion, right? Transition. Therefore, I am speaking about the voltages in between 0 to 1 or 0 to 5 volt. That is what I am speaking. That is what is going to give you transfer characteristics, means the relationship between input to output. That is what I will plot and then I will give you. Okay. Let me erase this. Now, transfer characteristics. This is your V in and this is your V out. Just now we are seeing when input is 0, when input is 0 volt. I am speaking with respect to voltage. Okay. Therefore, this is what is volt. This is also volt. Okay. When input is 0, what is your output? Output is 5. Let us say this is 5. When input is 5, when input is 5, what is output? Output is 0. Therefore, your output is 0. Okay. Therefore, we are only dealing with what? Extremities. But what about in between? Okay. Listen. Listen. Therefore, remember the meaning of transfer characteristics, right, is input is 0, under steady state what is output? 5. Input is 1, under steady state what is output? Input is 2, under steady state what is output? Input is 3, under steady state what is output? Input is 4, under steady state what is your output? Input is 5, under steady state what is your output? Which is 0. Therefore, when I say transfer characteristics under steady state, no timing information. The delay of inverter is not represented in the case of transfer characteristics, right? Therefore, input is given, under steady state what is output, and for a given different input what is under steady state what is output. That's it. That is what I am going to plot. Okay. Now, therefore, tell me input is 0. I am speaking. I am going back here. Input is 0. NMOS is off. PMOS is on. On, off. The 5 volt is coming at the output. Now, when I am increasing my input 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, no impact. Because the VGS of your NMOS should be greater than or equal to 1, then only it will conduct, else it will not conduct, right? Let us say the threshold voltage is 1, therefore up to 1 volt, you know, up to 1 volt, which is nothing but your threshold voltage of your NMOS, which is not, this is what people say, this is nothing but, let us say 1 volt, which is threshold voltage of your NMOS, okay, up to 1 volt. Why? 0, 0.1, VGS is 0.1, not enough to conduct. 0.2, not enough to conduct. 0.5, not enough to conduct. 0.7, 0.8, 0.9, 1, greater than or equal to 1, VGS starts conducting because threshold voltage is 1. Once till that point, till means less than 1 volt, your NMOS is off. When NMOS is off, only PMOS is the one which is what is always trying to have V out is equal to 5, 5, 5. Therefore, up to this point, your V out will be 5 only. Now, once the input is crossing 1 volt, then NMOS starts conducting. When NMOS starts conducting, right, then this is nothing but what? It is a on resistance. Now NMOS starts conducting. Therefore, it is taking some current. Means current and then current. You can say, you can treat like that. Therefore, this is also a current giving and this is also current. Therefore, current and current, the voltage will have some kind of division, voltage division between 5 to 0. Then your output voltage starts decreasing. Your output voltage starts decreasing. Why it starts decreasing? As input voltage is increasing, the strength of your NMOS is increasing. As the strength of NMOS is increasing, it is asking for more and more current. When I say it is asking for more and more current, then as Vin is increasing, the strength of your PMOS is decreasing. When the strength of your PMOS is decreasing, indirectly the resistance, equivalently the resistance of your PMOS is increasing, resistance of your NMOS is decreasing. If you see the resistor division, Rn divided by Rn plus Rp into 5 volt equivalently, right, then your Vout will be decreasing. Your Vout will be decreasing. Till what point? Till PMOS will enter into, PMOS enters into cutoff. For what voltage PMOS will enter into cutoff? I can say 4. Why? This is nothing but your VDD minus mod VTP. What is VTP? 1 volt. Mod VTP is 1. 5 minus 1, 4. Therefore, when this is 4, this is 5. Once the voltage is greater than 4, then the VGS, mod VGS of your PMOS is less than 1. PMOS is off. Then completely your output voltage will become 0. Because this is off, this is on, then completely this 0 will come to output. Okay? Maybe, therefore, then it is what is becoming 0. This is what people say the CMOS inverter characteristics. Right? Now, I want to explain one more point. I can explain a different way. Actually, in between, this will be current source, this will be resistor, this will be current source, this will be resistor, or both will be current sources. Fine. I'm not speaking those things. Those things, when we solve the problem, you'll understand, because there are problems when input is equal to something and then output are something tied, and then what is the reason of both the transistors, etc., etc. Always we need to know, we need to calculate VDS, VGS, VDS, VGS. If you know those things, we can calculate the reason of the transistors very easily, and then we can take the equations, current equations corresponding to the regions of the transistor. But when we solve the problems, you will understand. Now, let me explain a different way. What is PMOS trying to do? PMOS is trying to do what? It is trying to put 5 volt at the output. What is NMOS trying to do? It is trying to put 0 to output. That's it. Very simple. PMOS is trying to keep output 5. NMOS is trying to keep 0 at the output. Or PMOS is trying to pull up the node. NMOS is trying to pull down the node. Right? Initially, when you say input is 0, NMOS is not there at all. Only PMOS is there. Happily, individually, isolated. Right? It is simply pulling up. Simple. No fighting. Once V input is greater than or equal to 1 volt. Once the input voltage is greater than or equal to 1 volt, NMOS starts fighting with respect to PMOS, where your NMOS is trying to pull down the node because it is conducting the path. Because VGS is greater than or equal to VT, then it is also having some path, then it is trying to pull down the node, but at the same time PMOS is trying to pull up the node. Then fighting between PMOS to NMOS, which is stronger. For lower voltages, your PMOS is stronger. Why? For lower voltages, let us say 1 volt, VGS is 1 volt, but this is 4 volt, your PMOS is stronger. Therefore, your PMOS is trying to have more 5, but whatever made there is a fighting, then output voltage will be in between 0 to 5, but close to 5. Close to 5. As input voltage is increasing, as VGS is increasing, as the strength of NMOS is increasing, as the strength of PMOS is decreasing, then it is trying to pull down the node, but it is not able to pull up the node, slowly the output voltage is decreasing. At a particular point, the strength of PMOS is done, only NMOS is there, it will pull down completely the output voltage. Done. Therefore, this is what is our characteristics. I hope everybody understood it. I explained qualitatively, but there are quantitative related problems we are going to solve later. Okay? Means what's happening in between for different voltages and all. But remember, this is what is our transfer characteristics. But the same thing, input is 0, output is 1. Input is 1, output is 0. Okay? But when input is changing, your output will change. But remember, up to some 1 volt, output will not change. But from that point, it will change. But again, output is saturated because that is what is our this region. This is what people call it as noise margins. Even though your input logic 0 is having some noise, because 0 to 1 volt your output is 5 only. It is not changing. Similarly, even the 5 volt, instead of 5 volt is having some noise, still its output is 0. Therefore, that is what is giving you noise margins, right? Now, therefore tell me, when you give logic 0, you get logic 1. When you give logic 1, you will get logic 0. Everybody understood? Right? Done. Take this problem. Or take the graph. Therefore, this is what is our transfer characteristics. Okay? Exactly in this portion, here NMOS is off, your NMOS is off, but your PMOS is on. Here in this portion, your NMOS is pulling down, right? Therefore, your NMOS is on, but your PMOS is off. Okay? In between, both will be having, like, NMOS starts conducting, but it will be in saturation region, linear region, saturation, and linear saturation. Like that, there will be a transaction. Those things we will see later. Everything will not see at the same time. It will take time. Remember, digital circuits always deal with these two portions. Therefore, digital circuit always deal with this is what is called non-linear portion. Why? Even the input is increasing, your output is not changing. Here also, even the input is changing, your output is not changing. That is what we need. That's why noise margins are there. Therefore, these two regions are called non-linear regions. Here, this is kind of linear region because when input is changing, your output is also changing. In this portion, you can say pull down to pull up, or pull up to pull down fighting. Pull up, which is PMOS, to pull down, which is NMOS, fighting. But KCL, KVL should be satisfied. Therefore, which one is dominating? That depends on the input voltage. Okay? As the input voltage increases, your NMOS is dominating slowly. As NMOS is dominating slowly, then it is trying to pull down the node. Therefore, pull down the node. That's why this is decreasing. explaining the theory related to inverter, that's why it is taking time. We didn't go to the problem yet. Even though I just wrote it like discussing only problem number 2, right? That is always better. Problem, studying some theory, right? We will remember, because we always think to get the solution, to get the answer, right? That will motivate the theory, whatever you study, right? Through the problem, right? It will motivate you to get the answer. Means the theory you are trying to apply to get the answer. That is what we need ultimately, right? Hope this is what is done. Okay, then I will not rub it because I want to use and then I want to explain something. Tell me, this is one of the interview problems, okay, which I only faced from one of the startup companies, Cosmic Circuits. After my BTech, and I attended this the startup company, and then I got this one of the interview problems, and that is what I can explain, or I can ask you. Tell me the same thing. If you take inverter, right? Logic 1, logic 0, logic 0, logic 1, right? Tell me, what is output? Output means you can define. Therefore, what is output here? Your output is shorted to your input. Then what is your output? Okay, saying that 1 0 1 0 1 0 1 0 or 0 1 0 1 0 1, right? Everybody agrees? Because maybe, is this what you are saying? 0 is given, you will get 1. 1, if you give 0, if you give 0, you will get 1. Therefore, 0 1 0 1 0 1 continuously it is toggling, right? Right? Tell me, if I say this is 0, immediately this is 0. If this is 0, immediately this is 0, right? If you say this is 1, immediately this is 1. There is no delay element. That will not happen. That is not the solution. You may say 1 0 1 0 1 0, right? It is not ring oscillator. At least we should have odd number of inverters to get ring oscillation. This is odd number 1, but it should be greater than 1. This is not going to give a ring oscillation. But what is your output? Okay, now can I divide the solution for this, right? If I ask you the problem, this is what is one of the interview problem. This is one of the interview problems, okay? One of the interview problems. Then can I divide the problem into like this? Number 1, just only inverter. And this is your input, this is your output. And you know about the inverter, and we know the relation also, transfer curve, that is nothing but transfer characteristics. Okay? Now, and second one, this is nothing but what? When you say this is V in, and when you say this is V out, right? This is what your inverter. But now can I say V out is equal to V in? Just if you combine these two, that is nothing but this is the one, right? Therefore, what is this? Therefore, this is nothing but V out is equal to V in. Now, you know this, that is what is this graph. Now, incorporate this also in this, then the intersection of these two is nothing but the solution, right? Therefore, you know about this inverter and you know the graph between V in and V out. Now, what is V out is equal to V in? Y is equal to mx, where m is equal to 1. Then y is equal to x. What is y is equal to x? Straight line passing through origin. Straight line passing through origin. Therefore, this is nothing but V out is equal to V in. Therefore, what is the intersection point? Inverter and V out is equal to V in. Intersection point is this. What does that mean? Let us say if it is symmetrical CMOS inverter. Yes, this is symmetrical CMOS inverter. Both are having NMOS, PMOS having same strength. Therefore, what is that? That is nothing but when input is VDD by 2, which is switching point. This is what people call it as switching point. Then your output is also VDD by 2. Therefore, what is the solution? The solution is for what voltage your output is equal to input, that is the voltage. Don't think always like digital. 1 0 0 1 therefore toggle. No. We have to think like analog way. That's why I explained the transfer characteristics. Right? Therefore, when V in is equal to VDD by 2, your output is also VDD by 2. That VDD by 2 is nothing but switching point. Therefore, from that is what people, this is what is the logic 1, this is what is the logic 0. That's what people trade. Or threshold voltage. Threshold with respect to inverter. Therefore, now tell me, or I can explain with respect to the body language or with respect to the action. Input is 0, output is 5 5 volt. Input is 5 volt, output is 0. Now, input is changing. Definitely at a point, both will be same, right? That is nothing but 2.5, 2.5. Therefore, when input is 2.5, output is 2.5. When input is more than 2.5, output will be less than 2.5. Then when input is 5, output is 0. Therefore, it will settle to VDD by 2. Let us say VDD is 5 volt, then you will get 5 volt, 5 volt. Therefore, what is the answer? Therefore, answer is, if you take inverter having something like this, answer is VDD by 2. It will not toggle. It will stay at what? It will stay at switching point. Or if you say logic 1, logic 0, logic 0, logic 1, logic 0.5. There is nothing called logic 0.5, but I'm just saying that it is logic 0.5 or switching point. Okay, take it. Once you understand this, right? Now, or I can say easily you can understand the state of the circuit, right? 5 volt, 0 volt. What is input? Is it logic 1 or logic 0? It is not logic 1, it is not logic 0. This is logic 0.5 or switching point. And this is symmetrical CMOS inverter because Kn is equal to Kp. Then when input is VDD by 2, your output is also VDD by 2. Therefore, now you know output also 2.5. Then you know VDS, you know VGS, you know VGS, you know VDS. We can find the state of the transistor. We can take a corresponding current equation. We can solve. Therefore, straightforward. Once you know the region of the transistor, straightforward. We can use the current equations whatever I have given. Then we can solve the problem. I hope everybody understood the problem. I just explained the problem. Remember, right? This is what your CMOS inverter, but input is not defined with logic 0, logic 1. Input is defined with VDD by 2, which is 2.5 volt. Then what is output? I can say VDD by 2, which is 2.5 volt. Then I can solve the problem very easily. Okay, take it. Then we will solve the problem to find the current I. With that, the problem is over. Let me have some water. In the meanwhile, you try to take this. Using this, I'm explaining. That is what exploiter to explain the problem also. Okay. This is different. Okay. Done? Okay. Let's solve the problem. See, whatever analysis we did till now, that will help you to solve multiple problems. But again, while solving, you understand the difficulty, but yeah, when you solve one by one, you will understand. Everything should be incremental, as I told you before. We cannot get everything at the same time. Now, therefore, tell me what is output now. Therefore, here what is this output now? This is 2.5 volt. Now let's see the region of the transistor. We need to find, okay? Therefore, tell me, if you take NMOS, what is VGS? VGS of NMOS, 2.5 and then 0, right? Because this is gate, drain, source. For PMOS, gate, source, drain. Okay? Therefore, what is VGS? VGS is nothing but gate to source. 2.5. What is VDS? We have VDS is also 2.5. Therefore, what is the region of the transistor? Let us see whether it is in saturation or not. What is the condition for saturation? VDS should be greater than or equal to VGS minus VT. VDS is 2.5, greater than or equal to 2.5 minus VT. What is VT? VT is 1 volt. Therefore, 2.5 greater than or equal to 1.5. Is it true? Yes, this is true. Therefore, transistor is in saturation. Or I can say directly, you know what is that? VGS is equal to VDS. Equivalently, gate is connected to drain. Equivalently. Therefore, diode connected MOSFET, that will be always in saturation. Okay, fine. Now, if you take PMOS, what is mod VGS? You take mod VGS. What is mod VGS? 2.5 and then 5, right? 2.5. Actually 2.5 minus 5 minus 2.5, but mod 2.5. Then similarly, what is mod VDS? Mod VDS is nothing but this one, right? 2.5 minus 5 minus 2.5, therefore 2.5. Again, both are same. You need to same. Therefore, mod VDS is greater than or equal to mod VGS minus mod VT. What is mod VDS? 2.5 is greater than or equal to mod VGS. 2.5 minus 1. Therefore, 2.5 is greater than or equal to 1.5. This is true. Therefore, this is also in saturation. Remember, only at switching point or about switching point, both NMOS and PMOS will be in saturation. Then you will get direct current. Saturation means you will get direct current from power supply to 0. This is what people call it as short circuit current. This is what people call it as short circuit current. Because when input is 0, output is 1, and then output is, there is no static current. But remember, when input is changing, in between there is a short circuit current from 5 to 0. See, that current is not flowing, therefore it is not charging the capacitor. This is the current which is what is directly going to the ground, which is leakage, or this is what people call short circuit current, which is unnecessarily one of the components of your power consumption from CMOS inverter. Actually, there are 3 power components I can say. One is dynamic power to charge the capacitor and then discharging the capacitor. Number 2, static power means when one of these transistors off, because complementary, this is off, there is no current. If this is off, no current. Therefore, but because of high resistance, as I told you, leakage current will be there. That is what is static power. And something called switching power. Switching power means this is switching power. When input is changing from 0 to 1, and then when output is changing from 1 to 0, not only charging the capacitor, there is extra power which is what is going to ground also, other than the current which is what is going to the capacitor to charge. Therefore, this is also one of the extra power component which you are getting. Therefore, the total power is having dynamic power to charge the capacitor and discharge, which we need, which is what is changing the state of your circuit. Number 2, static power. If there is no change, if input is constant, if input is having state which is constant, then there is a power which is what is from power supply to ground, but one of the transistors is off, you'll get very small current, that is what is leakage current or static power. Third one is short circuit or switching power or switching current. That is because of this only. Okay, that is what is asking what is the switching current. Indirectly the problem is related to if you take any CMOS inverter with some strength, what is switching power? Indirectly that instant. Therefore how much is the current you have, then voltage into current, you'll get the power in that instant. Then how much is the energy which you are taking from your power supply, that we can calculate. That is what it is. Therefore both are in saturation. When both are in saturation, then what is your circuit? Your circuit is like this. And both are current sources, right? This is 2.5, therefore this is 2.5, here 2.5 you have, here also 2.5 you have, and both are current sources, and in series current is constant, same current is flowing from both PMOS as well as NMOS. Therefore either you can calculate the current from NMOS or you can calculate from PMOS, but we are familiar with NMOS, let's calculate current from NMOS, the same current is coming from PMOS also. Okay, now let's see, this is what is our NMOS current, this is what is IN, and this is what is IP. Okay, therefore what is IP, IN? IN is nothing but mu n Cox W by L of NMOS into VGS of NMOS minus VTH of NMOS, okay, whole square. Similarly, what is IP? IP is equal to, for your understanding I am writing, okay, mu P by 2, okay, 2P Cox by 2, I only told you, don't forget, I only forget now. Okay, W by L of PMOS into VGS of PMOS, I told, right, mod VGS of PMOS minus mod VTH of PMOS whole square, right? Tell me, mu n Cox W by L of NMOS, mu P Cox W by L of PMOS, both are same, therefore these two are same. VGS of NMOS, VGS mod VGS of PMOS, both are same, then both are having same threshold voltage, then both the currents will be same, right? You can take any one of these. Therefore what is your NMOS current? Therefore IN is equal to IP is equal to your I. Therefore I is equal to, can I write it like this, Kn by 2, I am taking NMOS, okay, Kn by 2 into VGS of NMOS minus VTH of N whole square. Therefore what is Kn? Kn is nothing but, which is given 40 micro by 2 into, what is VGS? VGS is 2.5 minus, what is VTH? 1 whole square. Once you know the problem, only just one equation to solve. That's it, very simple to get the answer if you understand the problem. It is expected to have this theory before solving before entering into the examination. Once you know this theory, now tell me how much time it will take to solve the problem in the examination. Only 2 steps. That's it. Okay. Therefore now what is this? I is equal to 40 micro by 2, 20 micro into 2.5 minus 1, 1.5. Can I write 1.5 as 3 by 2? Then 3 by 2 whole square, which is basically 20 micro into 9 divided by 4, 9 divided by 4, 4 5 jar, 5 9 jar, therefore it is 45 microampere. Therefore the current, the short circuit current, which is what is flowing from power supply to ground, is nothing but 45 microampere. What is the answer? How much time it took to get the answer? Therefore answer is C. Therefore answer is C. Over. I think it took around 1 hour, right? Because of the concept. But once you know the concept, once you know that IN is equal to IP, and then if you use the equation, saturation current equation, and we should know that both are in saturation, then only you have to use saturation current equations. Okay? Over. Then write down problem number 3. We can use CMOS inverter as amplifier also, but the input bias voltage should be switching point. About switching point, if you apply AC signal, it will amplify. That is what people call it as CMOS amplifiers. Okay. Almost all the problems we are solving, right, using ideal equations. Ideal equations means neglecting channel length modulation. Maybe the last problem in this session. Let's see whether we can complete that or not. Else it will go to next session. Okay, now the next problem, problem number 3. The small signal resistance dVb by dId in kilo ohm offered by N channel MOSFET shown in figure below at a bias point of 2 volt and device transconductance parameter mu n Cox W by L 40 microampere per volt square. Threshold voltage is 1 volt. Neglect body effect and channel length modulation. Therefore, indirectly asking us to take ideal models only. Okay. Now, therefore, the problem is MOSFET is given and asking for the resistance. Okay. Problem number 3. Therefore, this is what is bias VB, right? Now, this is what is drain, source, gate, NMOS, right? Given Kn is nothing but mu n Cox W by L of NMOS. This is what is given, which is 40 microampere per volt square, and threshold voltage VTHN is equal to 1 volt. Then asking for, what is asking for? The small signal resistance dVb by dId. Therefore, what is this current? This is, let us say, Id. Therefore, dVb by dId in kilo ohm. That is the problem. Okay. And is saying at a bias point of 2 volt. At a bias point of 2 volt means what is VB? VB is equal to 2 volt. That is what he is saying. Okay. Now, just treat it like black box. You treat it like black box. When you treat it like black box, but it is defined with some output, let us say this is what is VB, and it is defined with some output current IB. Then how will you define? Is asking small signal resistance, basically dynamic resistance. Therefore, the resistance offered by the black box, right? Let us say this is what is small r naught, right? Therefore, that is what your dynamic resistance. Therefore, small r is equal to, it's not VB by IB. If you take VB by IB, I told you, right? If this is non-linear, we should take delta VB by delta IB. That is what your dynamic resistance or AC resistance. That is what is asking. Therefore, indirectly is asking what is delta VB divided by delta IB. Sorry, ID. It is saying IB or ID? ID only. Therefore, this is ID. This is ID. Or differentiation dVb by dId. That is what he is saying, right? Differentiation or delta. That is what is asking. How will you get? Do you know VB to IED relation? Now go back to this. This is the definition. Now ultimately we should get it, right? Now, what is the relation? We know that this is nothing but what? We know this is diode connected transistor and this is in saturation. When this is in saturation, we know that, right? ID and this is in saturation. This is in saturation. Right? ID is equal to mu n Cox W by 2L into VGS minus VT whole square. Okay? Therefore, this is nothing but Kn, that is what is given. Kn by 2 or Kn is given. Yes, it is Kn, then it is Kn by 2, VGS minus VT whole square. This is what is ID, right? Therefore, ID is known to you, but what is VGS? VGS is nothing but VDS. VDS is nothing but VB only, right? This is VB. Therefore, ID is equal to Kn by 2 VB minus VT. Therefore, what is VT? VT is given 1 volt, 1 whole square. Then let's differentiate. Therefore, dID divided by dVB, if I differentiate, what you get is equal to Kn by 2, that is constant, into 2 into what? VB minus 1 into differentiation of VB. Then that is 1. Therefore, 2 will be cancelled. It is simply what? Maybe we will substitute that later. This is VT. Now this is what is VT. Okay. Then 2 will be cancelled. It is simply Kn into VB minus VT. Right? This is dID by dVB. Right? We got it. Then, but what is R0? Therefore, R0 is equal to delta ID by delta VB, which is nothing but, 1 divided by, okay. Therefore, what is that? 1 divided by Kn VB minus VT. You know everything. What is Kn? 1 by Kn is nothing but 40 micro and VB is nothing but, it's already given, 2 volt, 2 minus 1. Therefore, this is nothing but micro will become mega, right? Then it is nothing but 10 to the power of 6 divided by 40. How much is that? Is asking in kilo ohm. Therefore, if you take a 10 to the power of 3 out, then 10 cube, 1000 by 40, 10 by 4, 2.5, right? Therefore, I can say 2.5 kilo ohm. What is the answer? Something is wrong? 1000 by 40. What is 1000 by 40? 100 by 4. 100 by 4 is 25. Therefore, this is 25 kilo ohm. Fortunately, because 2.5k is not there. That's what. If you do silly mistake, something like this, let us say unfortunately, we have 2.5k in the option also, then we will choose it, right? That's why the calculations are very important. Don't do in a hurry way. Okay? Fine. Everybody understood? I can explain in a different way also. I think enough for this session. We just differentiated and then we got it. Actually, what is the differentiation of ID by VGS? GM. Basically, that is 1 by GM. For the diode connected transistor, if you ask me the resistance, how much resistance it is offering, the AC resistance, that is nothing but 1 by GM. That part I will explain later. First of all, you take this problem. Just with respect to the definitions, we took it and then we got it. Okay? K is nothing but mu n CR W by L. VB is nothing but VGS minus VT. 1 by mu n CR W by L into VGS minus VT, which is 1 by GM. The diode connected transistor resistance, AC resistance, is 1 by GM. Hope this is done. You can continue. I think the video will be there for 2 more minutes. Then we will see a little bit. I will explain the same thing, just the same point. Then it is straightforward. Okay, just to have the qualitative part. Okay, thank you.